Greetings to all my tech heads out there in the KevTechify Nation, and if you're new here, welcome. In this episode, we're going to look at access control. We'll be discussing authentication with local password, AAA components of authentication, authorization, and accounting, and finally, we'll talk about 802.1x. This episode is part of my series on switching, routing, and wireless essentials for the Cisco Certified Networking Associate, also known as the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. What we're talking about is accessing your devices on your network, accessing those networking devices. We're talking about routers and switches, maybe firewalls, adaptive security appliances, ASAs, those devices that run your network. We're not necessarily talking about operating systems at this point. What we're talking about is accessing those networking devices. What you're going to do is set up a password so that way you can use it to get into your virtual terminals, your telnet, your SSH connections. The easy way right here is to go into global configuration mode, and then we're going into our virtual terminals. What you have to do is you have to make sure you get the first 5 because those are configured as a group. If you apply a setting to one of them, it activates the other ones, but the settings don't get applied. So you got to make sure you have that range in there of 0 to 4. That's the minimum range. There are 16 ports available, so that's 0 to 15. Sometimes you see people say make sure you do the 0 to 15. I like to do the 0 to 15 because that covers all 16 ports. Technically, you only have to do the 0 to 4. I like to do the 0 to 15. It covers all of them, and that way you know everything is set. Then you come in and you set a password. I like this password to a degree. I mean, it's not as long as it should be. It should be longer. It should be 8 or 10 characters long. But it does have a couple things in it. It does have a lowercase letter. You should have an uppercase, so we're missing that. It's missing an upper, and so it's missing an upper. It's missing a symbol, like the @ sign, the pound sign, the dollar sign, the shift 2, the shift 3, the shift 4 keys. So it is missing that symbol. But everybody in today's world likes imposing letters to make sort of what we call leet speak. We changed the S to a 5, and that's what's happened right here. We changed the S to a 5. Then we changed the O to a 0. Oh, we're going to make our words complicated. And they do that to everything. And that's one of the first things a hacker does is that they're trying to attack your system. They start with a dictionary attack to make sure you don't use a dictionary word. Don't use a word that's found right in a dictionary that way. So what people do is, okay, let's go ahead and change the S's to 5s and the O's to 0s, the E's to 3s. And so that's what the hacker tries. And they substitute all of those in, and you can do that in a program, and it does it all automatically for you. What they did here is they actually skipped one. They didn't do that. A lot of times the I here gets changed to a 1, and they didn't change that. And so it's a mixed combination, and I really like that because you can't substitute all of them, and so it'll take your hacker longer to get through. Once you set that password, then you have to apply it to the login process, and that's what this last step is. A lot of times people forget to do that. Well, I set the password. Yeah, you set the password. Now we need to tell the login process to actually use that password. Don't forget that last step here. This is done. This is Telnet. If we recall, Telnet's a way to access the virtual terminal across the internet. But the bad part is, it is unencrypted. So it's unencrypted. Meaning, if somebody, a threat actor, that person that's trying to attack your network, was actually on your network and was able to sniff the traffic, or if they are connected into the same access point so they could see your traffic going through the air, they would see you when you typed in your password. This would come across in clear text. The C, the I, the 5, the C, and the 0 would come across in clear text, and they would be able to see it. Now they know your password to get remote access to your devices. The better solution is using SSH. the secure shell. And that's what this example down here. There's more steps to doing the SSH, but when that traffic goes across your network, it's encrypted. And once again, to review the steps here, first thing we need to do is set a domain. This domain here is part of the SSH protocol. You need to have a domain so that way it can look for the users in there. Personally, for me, I don't like to use the company's domain name. When you start doing that, you're probably going to run into issues on your DNS, because if somebody types in example.com in the web browser, it's going to go to your website. There's a good chance that if you have a Microsoft system with Active Directory and the Active DNS, that's going to use your domain name. What I like to do is, yes, use the company top level domain, so example.com, but I like to add in something like maybe network or something like that. So it's network.example.com. The network.example.com. That way it's different, but you still have your domain name. And you don't have to have just two parts to your domain name. You can have as many as you want. So up here is 3. If 4 is appropriate, that would also work. If you want devices.network.example.com, you could have that. Like I said, I traditionally don't use the first level domain name. After you do that, we generate our crypto key. That's the thing that does the encryption. That's the key used to make the encryption and then to unencrypt on the far side. This modulus is how long is that key? How long is the key for encryption? Some systems, when they generate the key, they give you a 512 key. 512 key has been found insecure. And actually, there's some clients out there that won't even use a 512 key because it's too insecure. And what I mean by insecure is they've been shown that with a key that short, 512 characters long, yeah, that's a really long character, but to computers and with computational power, what it is today, they can brute force that attack to figure out what that key is and get into your system. 512 is too short. Most client SSH applications require 1024. For good measure, a lot of people say use our 2048. Use the 2048. And by default, that's typically what I do. Then after you generate this key, it's going to give you some messages. It's going to give you some information in here. It'll give you a couple extra lines that wasn't showing up here. Then you create your username. You have to create these usernames on the system you want to log into. Once again, we're doing local passwords. And so you create the username. You can either say secret or password here. Secret encrypts this. So if you do a show run, it'll come across as random letters and numbers. If you put the word password in there, it's going to show exactly what you type. And then you have your password. And here, this, in my opinion, is a pretty good password. Besides being an example that we're showing everybody, it has everything. It has our uppercase. It has our lowercase. It has numbers, but we don't have a symbol. So that's why I say pretty good. It's not an excellent. We are missing a symbol. Older systems used to get tripped up on symbols. They used to not accept symbols in there. As systems have evolved, more and more operating systems, more and more different devices, they start to allow you to have symbols in your passwords. The common symbols, a lot of times the shift number symbols, those typically are accepted on most systems nowadays. The other symbols, the ones on the right hand, the side of the keyboard by the enter sign that aren't associated with a shift number concept, those some systems may include, some may not. Because if you include those symbols over there by the enter key, those actually come in as programming symbols. And then when you send that to a server, hopefully the server's set up to kick those out and you can't necessarily use them. But you should be able to use the exclamation mark, the @ sign, the pound sign, the dollar sign, the percent sign, the shift 1, 2, 3, 4, 5. You should be able to use all those in the system. That's the only thing I would add to this password to make it a good password. Then, after you have your passwords, we set up the version 2 of SSH. Version 1, it's a little bit older. It's not as secure. It doesn't allow you to do some of the changes you need to do. And a lot of the current clients nowadays don't support version 1 anymore. They only support version 2. So make sure you do that. Once you have the SSH set up, now we have to say, okay, let's go ahead and use that. That's where we go in here. We go into our line, VT virtual terminal, VTY 0 to 4. I prefer to use the 0 to 15. Make sure we cover all 16 of those. Then we have to say we're going to change that transport. Change the technology we're using to transport our data between the client and the server. That's transport. And so it's coming into the server. So it's transport input and then SSH. If you only want to do SSH and you don't want Telnet to happen, just put SSH right here. If you want to do SSH, but you also want to have the backup of Telnet, you can go ahead and put Telnet in there. But once again, Telnet's not secure. I wouldn't necessarily use it. And then the last thing you have to do is say log in, and then you have to tell it exactly what to use. We wanted to use the local password. So login space local, we're going to use the local passwords. Our local passwords are any user we set up here. And so when you go and you connect in with SSH, it's going to ask you for your username. It's going to ask you for your password. It has to be on that device. There are some limitations here with using the local password. First limitation is that it has to be a user you created. So it has to be here. If it's not a user you created on that device, it's not going to work. You can't log in using that. If you got 2 routers, you have to create that user account twice, one on one router, one on a second router. For a small network, this works pretty good. Imagine having 100 devices on your network. You hire in a new network person. You have to go around to each one of those 100 persons and add that in. The other downfall with using this login local is there's no backup. If for some reason you lose this username and password, you can't get into that system. You're going to wind up doing password recovery at that point in time. And to do password recovery, what I do is I go to cisco.com, I type in password recovery, and then put the model number of the device I'm trying to do. That's the easiest way for me to tell you how to do password recovery. Each system's a little bit different, but like I said, you lose that password, you can't get in if you just have login local. I hope you are liking this episode on access control. If you have the time, please leave me a comment and let me know what you think about access control. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. When we're thinking about giving access to a user to get onto our system, one of the things we should be thinking about is what we call AAA. Now, this is not the Automobile Association of America. What this is authentication, authorization, and accounting. These are the 3 steps you should be doing anytime you give anybody access to your system. First step is authentication. Who is permitted to get into my system? And typically it has the credentials there to get in there. Username, password, certificates required. And that authenticates the user. Who is that person? They authenticate who they are. Second one is authorize. Once they've authenticated, authorization is what can they do? They can get into this VLAN, but they can't get into the other VLAN. If it's a Windows system, they can see this directory, but not this directory. They can read this directory and can't make changes to it, but on their home directory, they have full control. And then the third A is accounting. It keeps track of what that person does. Once they've authenticated, once they got their authorization, now what did they actually do? Did they go in there and connect into a router? And we want to know that. Okay, this person is responsible for maintaining our routers, so that makes sense. But if this person connects into your router and is a shop floor employee, there's no reason he should be doing that. And so we can keep track of that. Did this person go into this folder and delete the HR manual? Well, then we have our permissions set up. We need to restore from backup and get it up and going. But these all work together. The authentication, the authorization, and the accounting. The authentication. There's kind of 2 ways we can do authentication. And once again, we're talking about authentication for our networking devices, the routers, the switches, any other devices on our network that supplies network functionality. We have local and we have server-based AAA authentication. Local authentication is what we just talked about, where you create a user local to your system and it's only listed there. And if you want to give that user access to another networking device, so a second router, you have to go and create that user there. It stores those names locally. It's not on anywhere else but that one device. They authenticate against that local device. And once again, it's ideal for small networks. 2-3 routers on your device, or 2-3 devices on your network, router, 2 switches. That's perfect. But when you start talking hundreds of devices, you don't want to have to go through and put those usernames on each one. That's where something like the server-based access control or AAA comes in. Routers, switches, other networking devices, they connect to a central AAA server. They connect to that central AAA server. So each router connects into that. That AAA server contains usernames and passwords. That way you only have to set up the username and password in one location and it connects back in. And then those devices connect back into that AAA server and use those usernames and passwords to give them permissions on your routers and switches, your networking devices. Now, there are 2 methods that we typically see. We typically see the remote authentication dial-in user services, or that's a radius. And the second system is the Terminal Access Controller Access Control System, or TACACS that you'll hear people say. I do love that name, Terminal Access Controller Access Control System. Radius or TACACS server, they are both 2 different types of servers. They both have usernames, they have passwords on them, they have permissions on what you can do, they have logging features. They all communicate with your end devices. And once again, this is set up for a lot of devices, a lot of switches, a lot of routers, whatever you have for networking devices. Normally, I don't use one or the other. Normally, I use both of these systems together. Now, why would I do that? Well, the server base makes it easier, especially if you have lots of users. So for me, this is lots of users, one location for username and password combinations. That's where it's stored. That's what it is. You roll out a new device, you connect it in, you point it to that AAA server. That's all set up. But I also set up a local password. And for me, this is the emergency account. And what do I mean by emergency is what happens when this server goes away for whatever reason. The server goes down. It gets unplugged. The connection to it is no longer working. Nobody can log into your devices. So I created an emergency account here. This account I typically set up with the username, about 20 characters long. And I use it randomly generated. So it doesn't make sense. So it's not administrator. And so I randomly generate that. Password I set up at about 30 to 40 characters long. So it's almost impossible to guess. Then what I do is I print it out, these passwords. Oh no, you're printing it out. Well, this is the emergency. And at this point in time, I go and I give it to somebody who's got some sort of way of locking it up. A lot of times the president has a safe in his office. A lot of times the vice presidents maybe have a safe. The vice president of finance has a safe in his office because a lot of times he has cash in that or something like that. Maybe you put it in the bank in your safety deposit box. If you're really concerned about that, what you do is then you divide your username in half. You give the front half to one person, you give the back half to the last person, you divide your passwords the same way. You split it in half. And then that way, anytime anybody needs to get into that system, They have to go to 2 people, get those lists, combine it for the username, combine it for the password, and then get in. But you are still able to get into those systems at that point. I've also heard the argument that if your server does get away and you can't get into it, your hard drive blew up on your Radius or your TACAX server. You lost all that information. Well, then you just do password recovery. Yes, that is a valid argument. Password recovery, that process, you bypass the boot up, you can load in the saved config after you're into that system and then change your password. Yeah, you could do that also. This password process up here, yes, it can be used for our networking devices. I also see this being used quite a bit for our network systems. In particular, like our Windows server, the administrator account. You never leave the administrator account, always strip out the privileges for the administrator account. So if a hacker does get into the administrator, there's no permissions, but I always create a user account with all the administrative permissions. I use this concept here, about 20 characters long, randomly generated. Password is really crazy. I split it in half. I give it to 2 people that can lock those up, and that's a good practice. Second step here is authorization. Once the person gets into our system, once they supplied that username and password, authenticating against the local database, the username and password that's on that device, or using some sort of server, TACAX or Radius server, then we figure out what can they do. Now, once they're authenticated, authorization doesn't require them to enter in their username and password together. It follows right away. We can see this. You can go in there and set different permissions. On a Cisco router, it's the different security levels that allow them to either see user exec mode stuff, privilege exec mode stuff, actually make changes. So there's different levels there. On a Windows system, once again, it's all the permissions. What can they do at that point in time? We call this a set of attributes, the security attributes associated with that account, the attributes associated with the authorization. And so that's used in conjunction on that AAA server. And finally, we have accounting, and that's keeping track of what's happening. It collects and it reports that usage. Depending upon the system, it may be just a log file that's got lots of text in it, or sometimes the system you're using will give you nice, pretty reports, or a lot of times you can take those log files, those text-based ones, and import it into a reporting tool where it gives you those nice reports. Some of the information we look at is, when did they connect in? Well, everybody should be connecting in during business hours. Well, Johnny connected in at 2 a.m. Okay, if Johnny's an IT engineer performing a system upgrade on your system, and he let you know ahead of time that, hey, I'm going to do this upgrade at 2 a.m., then that makes sense. But if Johnny is an office worker who only works 8 to 5 every day, and he shouldn't be working at 2 a.m. from at home, then maybe his account was compromised and the threat actor is using that to get access into your system. So it's doing that. And then we also keep track of what commands did they execute. Now, some people, they can open up Word documents. They can get into that if you're looking at a Windows system. On a Cisco system, if it's your intern, maybe it's just some sort of show commands they can execute. They can't actually go in and change IP addresses on interfaces. And so you want to keep track of that. How many packets, how many bytes did they actually send? How much work did they actually do? Well, if they compromised your system and got into your router and then connected to other devices, then there's going to be a lot of packets there. But if it was just Johnny doing that 2 a.m. system upgrade and it's a low number of packets, because all he's doing is changing some IP addresses on interfaces or something like that, well, then that makes sense. And once again, this all combines together. It combines with the authentication, the authorization, and in the accounting. And it's a very detailed log. It's really impressive to see what they can keep track of for that. And if they don't keep track of what you want for some reason, you can set up custom logs too to keep track of that. Another protocol we use to secure our network is 802.1x. What this is an IEEE standard. It's port-based access control. Port-based, meaning when a computer plugs into the switch, we're going to control what that device can do on our network based upon how they log in. Now, login could be through a username and password. It could be through a certificate on the server, a couple of different ways to authenticate, but it's going to be based upon what permissions you set up. The authentication server, it authenticates on what's happening when you connect to the switch before any network access is given to that device. You need to authenticate who you are, what this device is, before they give you access to the network. And how this works is the client, or what we typically call the supplicant, is the device that's connecting in. And they're asking to get permission. And what they have to do is they have to run a client version of the 802.1x compliant software. And it sits there, and anytime it detects that connection coming up, it runs. So it has to run a piece of software on it. Then when it connects in, it goes to the authenticator. The authenticator is this intermediary switch. And so it's an intermediary. I think I spelled that right. It's the intermediary. What that switch does is says, okay, this device connected in on this port. They gave me this credentials at this point in time. What it does is it sends a request to the authentication server. The authentication server responds back with saying, okay, it's authenticated. And we authorize it to do this. Have access to a certain VLAN. Have access to different networks. And so it's sort of an intermediary. We don't store any of the authentication on it. That's why it's called the authenticator. And then the last component here is the authentication server. This is where all of our credentials are stored. It validates the device, whatever credentials it gave, it validates it. So it's a certificate, username, and password. It also keeps track of the authorization, what they're doing, and of course we have the accounting. So it does do AAA, our service, the authentication, authorization, and accounting. One thing to notice here, this is a switch, but you could just substitute this in as an access point. The access point could be an authenticator, and it would communicate with that server. It was my pleasure to provide you with this wonderful episode on access control. If you like this episode and you got value out of it, and depending upon what platform you're using, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. In the upper right is my playlist for my series on switching, routing, wireless essentials for the CCNA. In the bottom right is one of my favorite videos that I linked just for you. Thank you so much for watching this episode of my series on switching, routing, and wireless essentials. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.